GCE O Level Mathematics, Lecture 9, Map Scale. Hello everyone, Dennis here. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. There are 3 learning objectives in this lecture. We will learn to understand the scale of a map, calculate the actual distance between 2 points and the actual area of a region from the readings on a map, and use ratio to solve problems involving model scales. Map scale. Let's look at this map. I believe this map will not be strange to you. It is a Google map. In Google Map, we will see this region, which means that this distance is about 2 centimeters and the actual distance is 200 meters. So let's look at the distance between Yio Chu Kang Primary School and Punggol Primary School. From here, if we measure the distance directly from the map, let's say it is 10 centimeters. Based on the scale, what is the actual distance in meters? Also, there is a pond in Punggol Park. Let's say if we calculate the area of the pond in this park is 8 centimeters square, what is the actual area in kilometers square? We will learn all these conversions in this lecture. Map scale and distance. A proper map has a map scale that shows the relationship between the distance on the map and the actual distance on the ground. A map scale is usually written in ratio from 1 to n or in fraction 1 over n. For example, 1 to 50,000 or 1 over 50,000, which means 1 unit length on the map represents an actual distance of 50,000 units on the ground. In other words, 1 centimeters is to 50,000 centimeters. Both quantities must be in the same unit. Then we can convert 50,000 centimeters to 500 meters, as 1 meter equals 100 centimeters. We also can convert the ratio to 1 centimeters to 0.5 kilometers, as 1 kilometers equals 1000 meter. A map scale in the form of 1 over n is also called representative fraction or just RF of the map. Let's look at this example. A distance of 4 centimeters on the map represents an actual distance of 1.2 kilometers. A. Find the RF of the map. B. On the map, the distance between 2 shopping malls is 8 centimeters. Find the actual distance between the 2 shopping malls in kilometers. C. The actual distance between 2 fire stations is 2.1 kilometers. Find the distance between the fire stations on the map in centimeters. Here's the solution for A. Given 4 centimeters is to 1.2 kilometers as mentioned here. 4 centimeters represent actual distance of 1.2 kilometers. It is also equals 1 centimeters is to 0.3 kilometers by dividing by 4 for both quantities. Hence, it is also equals 1 centimeters to 300 meters as 0.3 kilometers is 300 meters. 300 meters is 30,000 centimeters. Therefore, the ratio is 1 to 30,000. Hence, the RF of the map is 1 over 30,000. B. As we have known that the ratio is 1 centimeters is to 0.3 kilometers, 8 centimeters is to x kilometers. We let x to represent the unknown of the actual distance. From here, 1 by 0.3 equals 8 over x, which means that x equals 8 times 0.3, which is 2.4 kilometers. C. Again, as we know, the ratio is 1 centimeters is to 0.3 kilometers. Y centimeters is to 2.1 kilometers. So 1 over 0.3 equals y over 2.1. Y will be equals 2.1 over 0.3, which is 7 centimeters. Now, let's try this similar example yourself. Ali's house is 1.8 kilometers away from his school. He draws a map on his neighborhood area, and the distance between his house to his school on the map measures 9 centimeters. A. Find the RF of the map that Ali draws. B. On the map, the distance between two restaurants is 6 centimeters. Find the actual distance between the two restaurants in kilometers. C. The actual distance between two hospitals is 5 kilometers. Find the distance between the hospitals on the map in centimeters. You can pause the video and try to solve it yourself. Here is a solution. For A, given 9 centimeters is to 1.8 kilometers, as mentioned from the question. On the map, it measures 9 centimeters. The actual distance is 1.8 kilometers, which equals 1 centimeter to 0.2 kilometers. So we divide by 9 for both quantities. 0.2 kilometers is 200 meters, and 200 meters is 20,000 centimeters. Therefore, the ratio or the map scale will be 1 to 20,000. Hence, the RF equals 1 over 20,000. B. As we know, the scale is 1 centimeters is to 0.2 kilometers. Hence, 6 centimeters is to x kilometers, which means 1 over 0.2 equals 6 over x. X will be 6 times 0.2, which is 1.2 kilometers. For C, and again the ratio is 1 centimeters is to 0.2 kilometers. Y centimeters is to 5 kilometers. So 1 over 0.2 equals y over 5. Y will be equals 5.0 over 0.2, which is 25 centimeters. Map scale and area. Consider the following scenario. The actual dimension of a football field is 120 meters times 90 meters. The football field is drawn onto a map with the scale of 1 centimeters to 10 meters. Hence, the dimension of the football field on the map will be 12 centimeters times 9 centimeters. From here, we can calculate the actual area, which is 120 meters times 90 meters, and we get 10,800 meters square. On the other hand, the area of the football field on map is 12 centimeters times 9 centimeters, which is 108 centimeters square. Now, we can find the area ratio, which is 108 centimeters square to 10,800 meters square, which can simplify to 1 centimeter square to 100 meters square. The 100 is 10 square, which will give us 1 centimeter to 10 meters square. And we can see that it is the ratio of the length square. In general, let's say there's a square on a map with the side of a centimeters. The area of this square is a square centimeters square. And the actual shape of the square is r centimeters and r centimeters. So the area of this actual square is r square centimeters square. The scale is a to r. The ratio of area will be a square r square. As we can notice here, to get the ratio of the area, we can just square the both quantities of the scale. Let's look at this example. The scale of a map is 1 to 25,000. A. A school campus in a rectangular shape is 5 centimeters by 3.5 centimeters on the map. Find the actual area of the school campus in kilometers square. B. If the actual area of a small village is 5 kilometers square, find its area on the map in centimeters square. Here's a solution. For A, there are two methods to get the answer. Method 1 is given the ratio is 1 to 25,000, which means that 1 centimeters is to 25,000 centimeters. 25,000 centimeters is 250 meters, and 250 meters is 0.25 kilometers. Hence, the ratio is 1 centimeters is to 0.25 kilometers. So we square both numbers, we'll get the ratio of the area, which is 1 centimeter square to 0.0625 kilometers square. So we form the ratio 5 times 3.5, which is the area of the school campus on the map, is to x kilometers square, which is 17.5 centimeters square is to x kilometers square. So x will be 17.5 times 0.0625. As we know, 1 centimeter square is to 0.0625 kilometers square. So 17.5 centimeter square will be equivalent to 17.5 times 0.0625. And we calculate the value, we get 1.909 kilometers square, rounded off to 3 different figures. There is another method to get the answer, which is the ratio of the map is 1 centimeters is to 0.25 kilometers. So 5 centimeters is to 0.25 times 5 kilometers, because we want to convert the actual length of the rectangular shape, right, from 5 centimeters is to kilometers, which is 1.25 kilometers. So we repeat the same process for the width, the width of the rectangle, 3.5, convert to kilometers, which is 0.25 times 3.5, and it is 0.875 kilometers. Hence, the actual area will be 1.25 kilometers times 0.875 kilometers, and the answer is 1.09 kilometers square, rounded off to 3 sequent figures. For B, as we know, the ratio of the area is 1 centimeter square is to 0.0625 kilometers square. Hence, y centimeter square is to 5 kilometers square. To get the value of y, it is 1 over 0.0625 equals y over 5. Y will be 5 divided by 0.0625, which is 80 centimeters square. Now, you can try this similar example yourself. The scale of a map is 1 to 500,000. A. The distance between two cities on the map measures 25 centimeters. Calculate the actual distance in kilometers. B. A campsite has an area of 240,000 meters square. Find the area of the campsite on the map in centimeters square. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, given the scale of the map is 1 to 500,000, which means 1 centimeters is to 500,000 centimeters. 500,000 centimeters is 5,000 meters. 5,000 meters is 5 kilometers. Hence, the scale of the map is 1 centimeters is to 5 kilometers. So, the distance between the two cities on the map is 25 centimeters, and convert to the actual distance, which is 5 times 25, we get 125 kilometers. Hence, you can write this sentence, the actual distance between the two cities is 125 kilometers. For B, as we know the scale is 1 centimeter is to 5,000 meters, we square both quantities, it becomes 1 centimeter square is to 25 million meters square. Alright, so why we want to convert to meter square? Because the questions give us the area of this campsite in meters square. Alright, as mentioned in the previous example, there are two methods to get the answer. I will just show you the first method. Alright, so given that the actual area of the campsite is 240,000 meters square, we let y to represent the area of the campsite. So it will be 1 over 5,000 is to y over 240,000. So y will be 240,000 over 5,000, which is 48. Hence, the area of the campsite on the map is 48 centimeters square. Scale and model. Scale can also be used in model drawing and floor plans. The same principle applies. For example, let's look at this diagram. This is a typical floor plan of a bedroom. Let's say the scale of this floor plan is 1 to 50, which means 1 centimeters represents 50 centimeters. Let's say the length of this cupboard is 2.5 centimeters. What is the actual length of the cupboard? It will be 2.5 times 50, which is 125 centimeters. As based on the scale, 1 centimeter is 50 centimeters, so 2.5 centimeters will be 125 centimeters for the actual length of the cupboard. Now, if the actual width of the bed is 95 centimeters, which is here, what is the distance on the floor plan? So let's say we label this as x centimeters. So x will be 95 divided by 50, which is 1.9 centimeters. Let's look at this example. The area of a living room on a floor plan is 1 by 6,400 of its actual area. A. Find the scale of the floor plan. Give your answer in the form 1 to n. B. The actual width of the living room is 3.6 meters. Calculate the width in centimeters of the living room on the floor plan. Here's the solution. For A, given the area scale is 1 to 6,400. To get the scale of the floor plan, we square root both quantities, which is square root 1 to square root of 6,400, and we get 1 to 80. So this is the scale of the floor plan. For B, given the actual width of the living room is 3.6 meters, we need to convert it to centimeters before we can find the width in centimeters of the floor plan. So 3.6 times 100, we get 360 centimeters. So the width of the living room on the floor plan will be 360 divided by 80, and we get 4.5 centimeters. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friends. Until then, see you in the next video. Have a great day ahead.